My stroke was in February 2017, and working at the things around the house that I needed to do, I really couldn't do any of them. When I try and do the daily things, I'm always reminded how difficult it is for one-armed person to get around in life.
Constraint-induced movement therapy, or CIMT, is a form of therapy where the non-affected arm and hand is restrained after stroke, thus forcing the patient with stroke to use their affected upper extremity. It is one of the only effective therapies that has been widely adopted for stroke, and thus a good benchmark to compare newer approaches to. But it does have many limitations, because you can imagine that if you restrain the good upper extremity for a patient with very little use of their affected arm, that would just lead to more restrictions in their everyday life.
We're trying to flip that paradigm and actually encourage a person to use their impaired arm. So our team is developing a device for the shoulder to provide support so that a person is able to better move their own arm. And ideally then practice moving their arm at home in order to get better so that they don't need the device anymore. The way that we're doing that is we have our soft wearable robot technology. This incorporates a balloon that is underneath the arm that inflates when a person is trying to lift the arm. We detect that they're trying to lift the arm with wearable sensors and machine learning algorithms. And so what we envision is that initially, after a person has suffered a stroke, they may need more support. But then over time, as our sensors allow us to understand how a person is recovering or getting better, we can actually decrease the level of support that the device is providing, and then encourage a person to be able to try and do the movements completely on their own.
So how else can we be learning about their movement? How else can we be learning about what they're doing at home? This is where we need software development and sensor development to help us fill in that picture.
We can use wearable sensor data to understand how a person is recovering and decrease the level of support over time to help them use their affected limb more. And so we're trying to collect large-scale sensor data so that we can study both unimpaired and impaired movements using biomechanics and machine learning to really understand this rehabilitation process.
Maintaining user motivation is critical for rehabilitation. Wearable sensors can be used to monitor progress and give users and therapists feedback. We see an opportunity to model user motivation over time with machine learning so we can reinforce positive behavioral change for frictionful tasks like home rehabilitation.
Our current partners are Harvard University, Massachusetts General Hospital, and Imago Rehab. And collectively, we bring expertise in the area of the development of soft wearable robots, expertise on stroke recovery and stroke rehabilitation, but also the deployment of these technologies to patients and in the real world. And in particular, teletherapy, which is really where we see the future of rehabilitation going. So it's been very exciting to be part of the NSF Convergence Accelerator program. It's allowed us to assemble a multidisciplinary team that incorporates engineers, clinicians, therapists, apparel designers, industrial designers, so a wide range of different individuals. And it's really that team that is critical in order to try and develop and deploy the types of technologies that we're working on.
I opened the fridge with my right arm, which is really hard because that's a tough fridge to open. And I moved the cup. Well, you saw how it was without the device on. It's really exciting that, you can do these things after 6.5 years. This is good.